Thanks for stopping by to check out yet another fun-filled, action-packed episode of Vintage Audio Review. In this episode, I'm going to talk about this JBL SA660 Integrated Amplifier. In 1969, JBL sold this for $450, which would be about $3,600 in today's money. It was a very pricey piece of gear for the time. It was rated at 60 watts per channel into 8 ohms at not more than 0.2% THD and had a frequency response of plus or minus 3/4 of a dB from 20 Hertz to 20 kilohertz. It is actually composed of two different pieces. If you look at my episode number 46 on the JBL SE401, I talk about just the amplifier section, which would have been its own piece, and it's kind of like they married the two. There was an option for a wooden case around this as well. This does not have that option, and we'll give a tour of it because it's a little unique in some of its in some of the ways it does things. This was brought to me by my good buddy Richard in pieces. It had been at a shop for a year or two, and not much had been done to fix it, or if the guy got frustrated. I don't really know all the details, but I usually will not take a job where everything is in pieces, more or less, and I'm asked to figure out how to put things back together and fix the problem. It did have a blown fuse, and after replacing the fuse and hooking it up to a variac and slowly increasing the voltage going to it, the current started getting higher than it should be, and I shut it off. And ultimately what I found was one wire had come off on one of the biasing diodes, and I'm guessing that caused it to draw too much current. I'll show a picture where it is in the circuit if I'm able to. Once I figured out the cause of the overcurrent condition and was able to get the thing up and running, I tested it. You'll see the data, and I listened to it as well, and I will get into that part of the video a little later. So right now I'm going to give a tour of the front and the back and the underneath, and then I'll take the cover off and you can peer into the inside of this JBL SA660 amplifier. Here we have the rear of the JBL SA660, and we can see that we have our speaker jacks here, and they are the push down and put the wire in, not my favorite. We also have a slow blow fuse here, and this guy right here is our power connector. And let me show you, hopefully that shows up. So this right here is the cord. I had to make a special cord for plugging in there, and I found this adapter at Harbor Freight, and I just hooked up an old cord to it, and the ground terminal is grounded. It doesn't have a ground terminal, but it is connected for the other end of the power cord that I made for this unit. This obviously is the front of the SA660. Starting on the left, we have our power switch. Now, I should point out that all the toggle switches seem to work well. They do have like a little slop to them, or they're real easy to move, but I never noticed any problems, and they're kind of cool looking, I think. Here is our 1/4-inch headphone jack. Here is our volume control here, our balance control here. Now I should point out that none of the controls are detented, other than the function control, of course. Here is our bass control, which has separate left and right bass control potentiometers, and this is our treble control with separate left and right potentiometers for each channel. Here is our selector switch. We have selections for auxiliary, tuner, phono 1 and phono 2. This is our stereo mono switch. This is our tape monitor on-off switch. This is our test normal switch. I'll get back to that in a moment. And here is our loudness switch. Now I'm going to go ahead and flip this on, and hopefully you can see that it's now red when it's in the test mode. This is JBL's aural null balancing circuit, and I'll get more into it in the data, but it's designed to help you balance between the left and right channels, and I talk about it in the data a bit more. This is the underneath or bottom side of the SA660. And starting on the left, we have an unswitched AC outlet followed by two switched AC outlets. We have our tape monitor output here and our tape monitor input here. Here's our auxiliary input, our tuner input. This is a unique feature that I have not seen on anything, and this is a balance control for your magnetic phono 1 input, so that you can adjust this to make sure the balance between left and right channel is good, and then you don't have to play with the balance control on the front for other sources. We also have a gain switch here for the phono 1 input, and it has low, medium, and high. I did my testing in medium, and this is the magnetic phono 1 input, and then this is our magnetic phono 2 input there, and here is our ground lug, which is one where you would push the wire into. And you can just kind of see this right here is part of the power supply amplifier stage here. This is a view of the JBL SA660 with the top cover removed. The amplifier power supply section is this area right here, and this right here is where the power amp gets its signals from the preamp, and then you have some power supply wires here to the preamp section, which is over here, and I'll show a view of that in just a moment. I do believe that this has been repaired at some point. As I mentioned earlier, this unit was brought to me basically separated in two, and things weren't mounted, and anyway, it looks like these guys here may have been replaced. Normally these are more like a different kind of transistor package, but for whatever reason this apparently works. It's actually kind of a good idea as long as these devices meet the specs of the original transistors that were in there, and it kind of looks like there may have been a few resistors here replaced. So anyway, that's kind of what it looks like. Now, the reason that this thing was blowing fuses was on the channel underneath here. This little red wire had come loose, and that is for the D1 through D5 diode bias assembly. There are, I believe, 5 diodes in series, and they are used for biasing the output devices. And it turns out in the service manual it says one of the reasons for blowing fuse would be if that is open or defective. So that was really the problem with it, and maybe whoever had it before me had replaced all the shorted devices but missed a wire, or it came loose and then it was blowing the fuse. That's kind of what it looks like from that view, and the speakers connect in the front here. So I'm going to flip it over so you can see the other side. This view shows the control side of the SA660. This is our volume control, and here are the loudness and tape monitor and test and mono stereo switches here. I don't know if you can see it. The headphone jack is down there and our power switch is there. Here we have the THD SNR at 1 kHz with the SA660 putting out 5 watts into 8 ohms, and the volume control is adjusted to give about 25 dB of gain. I should point out that the input that I'm using is the auxiliary input, and all the tone controls are set to mid-range. The loudness is off, and you can tell that the SNR is not too bad for something this old at 63 dB of SNR, and the THD is less than 0.2%, which is the maximum THD per the specification of this JBL SA660. I'm going to go ahead and see what the harmonics look like. So here we have a plot of the harmonics under the same conditions, and you can see that the odd harmonic, the third harmonic, is higher than the even harmonic, and that is about what you would expect with a solid state design. Here is the frequency response of the SA660 using the auxiliary 1 input, and we're putting out 5 watts into 8 ohms. The specification is plus or minus 0.75 dB across this band, and we're almost there. We're not quite there at the very low end of the band, and at the very high end of the band, at least for the left channel, we're not quite there, but we're pretty close. Could probably do a little bit of tweaking of the bass and treble controls to maybe adjust these, but overall this looks fairly acceptable in my book. Right now we have the SA660 putting out 37 watts into 8 ohms, and the THD is, at least for the left channel, is teetering at 0.2%. The maximum THD for this unit is 0.2%, and the maximum rated continuous power is supposedly 60 watts. So I'm going to slowly crank up the power until the spectrums here get looking pretty ugly, and we'll just see how much more power we can get. And this right here will indicate the power is being changed. We change a little bit there, go up a little bit more. We're still not bad. So right there we're starting to see the left channel THD is 0.25%, and you can kind of see that here. If I get rid of the right channel, you can just see the let me get rid of the left channel, so you can see the left and right channel look pretty much the same. I'm going to go ahead and increase the amplitude a little bit more. 42 watts. We're still less than, I'm going to shoot for 0.5% THD and see where we can get. So right about there is the limit I think I would call the power, which is about 43.5 watts. So that is worse than the spec limit of 60 watts, and we have 0.5 dBV going in. Our SNRs are actually looking pretty good. The spec is 72 dB, and we're about 72 dB, I'll call it. And so overall, it's not looking overly bad. Probably could go up a little bit more. So 44 watts, we're still less than 1% THD. So that is the max power that I would want to run out of this unit. And also note that the gain is set for 25 dB here. This plot shows the THD versus frequency for a couple different output power levels, and that's into 8 ohms, going from 2.5 watts to 20 watts. And the worst case THD that this ever experiences is about 0.2, 0.3, 0.4. So it's less than 0.4% across the band at a maximum of 20 watts and a minimum of 5 watts. The THD was specified at 0.2% or better, so it's not quite there, but it's still pretty good considering the age of this and that it is all original. Here we have the JBL SA660's output impedance. It's about, we'll call it 0.4 ohms, mid-band. Both channels are fairly close. If you divide 8 by 0.4, you come up with a damping factor of 20. The specification is 32, so it's not quite there, but it's 20 is still not bad compared to other amplifiers that I have measured. This plot shows the crosstalk or isolation between the left and right channels. In this case, the auxiliary input is being used, and the SA660 is putting out 5 watts into 8 ohms. The right channel input is terminated into a short, and then the signal is just applied to the left channel. And we're seeing an isolation of better than 45 dB through most of the band, except right here where we have our 60 hertz hum feed through. There is no specification for the crosstalk or isolation between the two channels. This plot shows the isolation between the tuner input and the auxiliary input. In this case, a signal is applied to the auxiliary input, and the tuner input is selected and its inputs are shorted. You would like this to be as low as possible, and we're not so bad at -7 dB isolation between the channels, and then it starts getting worse with our isolation only being about 15 dB here at 60 hertz, and then it gets a bit better to maybe 45 dB at 120 hertz, and at 180 hertz we're about 50 dB down. There is no specification for the channel-to-channel isolation. Here we have the noise of the SA660, and in this case my gain is still set for 25 dB of gain per channel. I'm using the tuner input, and those inputs are connected to shorts. So we're kind of just looking at some power supply hum bars here and here and here at least. There is no requirement that I could find for the system noise level of this unit. Once you get about a kilohertz, you're at least 90 dB down, so that's not too bad for something this old that still has its original capacitors in it. This right here is not so pretty at about minus 45 dB down or so, so most likely there is going to be some hum when you listen to it. Hopefully it is not objectionable. Here we have the THD and SNR at 1 kilohertz with the SA660 putting out 1 watt into 8 ohms. And there is a specification that for a 1 watt output with a signal going into the tape monitor input, you should have a THD of 0.1% or better, and I would say we're basically meeting that. The gain has been set, as it has throughout all the testing, for about 25 dB. Right now, I wanted to show what happens when I turn on the loudness switch. We are looking at the frequency response from 20 Hz to 20 kilohertz. In this case, we're going from the auxiliary input to the 8 ohm loads, and we're probably putting out about 14 watts into those loads. Focus on the area in here when I flip on the switch, which I will do now. Depending on the channel, it looks like it boosted those low frequencies, say below maybe 70 Hertz by, I don't know, 8, 9 dB, something like that, because we were in the minus area here. So that's kind of what it did. It really didn't affect any of the high frequency or the mid-range area at all. This is the multitone test, and it is showing that the distortion-free range is anywhere from, I would say maybe 10 bits to a little over 11 bits down here. It does seem to have some issues down at the very low part of the frequency band, but beyond that, for something this old, that is not that bad at all. Here we have the THD SNR response at 1 kilohertz for the Phono 1 input with the gain set for the medium setting. The measurement is taken at the tape monitor output. The SNRs look okay for a phono stage. It's about 46 dB. The THD is less than 0.03%, which is pretty good. We do see our power supply hum in this area. And the other thing that I should point out is I do have the RIAA curve on. If I go ahead and turn that off, it's going to add a slope to the response. So it kind of has this slope here. And if I go ahead and turn the RIAA weighting on, it kind of levels that out and it improves the numbers a bit. Here we have the frequency response of the Phono 1 stage. In this case, a 4 millivolt signal is applied, and the phono gain is set to medium, and the output is measured at the tape monitor output. The specification, as best I can tell, is plus or minus 3/4 of a dB, and we fail that. It's not so bad until we get to the very high end of the band here. We also do have some channel separation that is not great in this range, probably a dB. The channels are only balanced within, and these little glitches here are the power supply filtering hum. It's not the worst frequency response that I've seen, but it certainly is nothing to write home about. Right now I wanted to show what happens when we flip the test switch on the front panel of the SA660. Now, according to the manual, JBL has an aural null stereo balancing system for simple exact balancing of the stereo installation. And basically what it assumes is that you have a mono signal going into both the left and right channels. In this case, I'm using the auxiliary input, and you would adjust your balance such that you did not hear any sound or until you heard the least amount of sound coming out of both speakers. So I thought I would see what happens here. Now we do have this thing set pretty darn close because I have my meter and we're putting out what 5.2 watts in the left channel and 5.23 into the right channel. So I'm going to go ahead and flip that switch and we'll see what happens. Wow, that dropped it down quite a bit. We're getting maybe 1 milliwatt out of each channel, and you can see all the noise, and we can see that everything has been attenuated or has been canceled out because it is so well balanced. Now, just for grins, I will move the balance control a bit off center by quite a bit, and you can see right now I've got it moved quite a bit to one side, and you can see we're at about 620 milliwatts going to the speakers, or the loads actually. We probably would be able to hear that depending on our speaker system. So you would adjust your balance control such that the sound coming out of these speakers was as small as it could be. This is the only unit I've ever seen that has this feature, and I think it's kind of cool. For my listening test, I connected the SA660 to my Wilson Watt 3 Puppy 2 loudspeakers, and the music source was my Surfans F20 music player. I listened to quite a variety of music at different levels, and I thought the SA660 sounded just fine. I didn't find myself thinking, oh, I need a little bit more bass or treble or mid-range. Now, I did listen to it with the loudness on because I do like the extra bass, and I thought it did a good job. I did most of my listening between 1 to 3 watts of output power, and I did have my realistic APM 100 power meter hooked up. I did quite a bit of listening between 1 to 3 watts of output power, and I was typically around 80 dB SPLs, and then I bumped up the power to where I was hitting 93 dB SPLs and was putting out about 50 to 60 watts of power. Now, when it was putting out that kind of power, I didn't hear any distortion whatsoever, and I just kind of backed it off from that point on and just kind of listened to it lower. Now, the heat sinks are this front panel, so that got a little warm, maybe 105 F, and the top stayed fairly cool, maybe in the 90s, but it's basically a cool running amplifier, and I really enjoyed listening to it. As far as the hum with no signal playing and the volume controls down low, you can still hear hum out of each speaker as you would expect from the data, and it's not objectionable. It's more or less par for the course for vintage gear that I have listened to and measured, and once you get a few feet away and music playing, you know, the hum's not really a factor. Now, when I powered this on, I heard a slight little, like a thump, kind of a click thing, very minor, just kind of normal that you would expect. And when I turned the unit off, you would hear just a small amount of hum bleed off, and then it's totally quiet. So it really wasn't anything objectionable at all. My other little quirks are the way that you don't have a lot of room to connect your RCA inputs to. You have to probably use 90-degree RCA bends to get your cables in and out of here, or have a very small back connector area on the cable so that it would fit in and clear this. I'm not a fan of those JBL push-in terminals, at least not these. So those are just little quirks. I'm sure that the owner of this is going to be very happy to get it back and be able to hook it up. The controls are, you know, nice solid feeling, and it was just kind of fun to listen to it and test it and all that. Once again, if you liked the video, please hit the like button. If you have not subscribed, that would be a nice thing to do. And if you have any comments, I would like to hear them. Until next time, have a great day or night.